Why do bubbles get bigger as they reach the surface? Before we talk about the bubbles, we must first understand the principle. Now, as bubbles go up to the surface, it gets bigger because of the Boyle's law. The Boyle's law was developed in the mid-17th century by the Irish scientist Robert Boyle. He stated that if the temperature remains constant, the volume of a gas varies inversely as the pressure changes. Good. The Boyle's law is a formula of V1 times P1 equals V2 times P2. Now the V1 is the volume initial, the P1 is the pressure initial, and the Vf and Pf is the volume and pressure final. The Boyle's law is related to the bubbles getting bigger as they rise to the surface because in the bottom of the sea there is more pressure than the top of the sea. And since the Boyle's law states that when pressure initial times volume initial equals constant, or pressure final times volume final, when there's a lot of pressure, the volume has to go down to reach constant. And when it's in the top of the surface of the sea, since there's less pressure, there must be more volume. This happens because in the bottom of the sea, the pressure shrinks the volume because there's more pressure on the outside than the inside. Now on the surface of the sea, since there's less pressure, the volume won't shrink as much. And this is why bubbles get bigger as they rise to the surface. If you look at a film of a water balloon being launched, you can see that it's never completely filled. If this is in this full capacity, a water balloon is usually at this state. This is because as the water balloon goes up thousands and thousands of feet, the pressure gets lower, and because of that, the volume gets bigger. And eventually it bursts. This is one of the examples of Boyle's law being used in everyday life.